Hello everyone and welcome to another AP Computer Science video. This video is going to continue with even more array examples to see common algorithms in dealing with multiple pieces of information at once. Arrays again allow us to hold many items of the same or elements of the same data type within one group, and so it's important to be able to manipulate them, look through them, determine different information from them. So we'll do two main examples here today. The first one I would like to do is also a very common thing to do with arrays, and this is counting the amount of something. So for example, if we have a collection of numbers, we might want to count the number of odd values. And so that's a summation, but not of just the values, but of how many we see. Or we might want to, given an array of booleans, count how many trues we see, or something like that, or determining if we see an even a number or odd number of values. And so our example, what we're going to do is we're going to have an array of strings, and we're going to return the number of those strings that contain at least two vowels in them. So for example, if we have the word apple, it would count towards our score because apple has an A and an E in it. If we had the word chair, it would also count because the A and the I. If we had the word win, W-I-N, we could not include it because there's only one vowel in the word win. And so we may have an array of many strings, and we want to return the number of those individual strings that have at least two vowels in them. So to make this a little bit easier and to reaffirm in our minds that it's an effective strategy to make methods that do something and then apply them or use them in other methods, let's first make a method that simply, given one string, returns the count of vowels. So we'll start with that first, and we'll say, and I'll give you a moment to implement it yourself and we can match it, but let's go ahead and set the signature up together. It's public because we want someone to use it, static because we don't have a context. The return type will be int because I want to know how many vowels we see, and we'll go ahead and say vowel count will be our name. Our input will be a string, and we'll call it word. And so now I would say pause the video, try to implement this method. The method is again going to return the number of vowels seen. Vowels are A, E, I, O, U. Y does not count as a vowel. So go through this given string word and return the number of vowels seen. So pause the video, try it out, and then come back in a moment. So I hope that you've tried to implement this method. We can see now it's not too complicated. We've done this before. We've done the act of looping through individual characters, which very much mimics looping through an array. So let's try doing that together. I'll say we should keep track of a count and start off with 0 vowels and look at every character in our string. So for int I equal to 0, I less than word dot length. Remember this important detail, because word is a string and not an array, the length is a method and therefore has parentheses. As we go through every single individual index, I is a great index into the string. We can simply say if the, and actually maybe to make it a little bit shorter, let's go ahead and say string cur is equal to word dot substring I to I plus 1. Remember, if we always want to get one character and we're at the ith position, I to I plus 1 is great for substring because it's not inclusive of the second one. So we're basically getting one character at a time. And let's also do a dot to lowercase because it's possible that there's a capital vowel and we want to count those as vowels. So we'll ignore the case as we do that. So now we can simply say if cur is equal to an A, or cur is equal to a E, or cur equal to an I, and then I'll go to the next line, or cur is equal to an O, and then the last one, or cur is equal to a U. If any of those are true, then we can increase our count by 1. And otherwise, we just let our loop go about its business. And at the end of this loop, we will have looked at every character in range safely, and we can return count. If it's 0, it's 0. If it's not, that's great. So return count. So there it is. So now that we have this method, we will be able to apply it or use it in the bigger picture method, which is the array method. So I'm going to shrink it down, because all we really need to know is the name. We pass in a string and we can call val count. So now let's go ahead and do the work of looking through the array. Let's make another method, and I'll give you an opportunity to implement it as well again. So we'll say public. We want it to be static because we don't really have a context outside of just calling the method. And so again, the goal of this method is, given an array of strings, return the number of strings that have at least 2 vowels. So we'll say int because we want to return how many have at least 2, and we'll go ahead and say at least 2. And then our input is an array of strings. Not one string, but many strings. The idea is that we could potentially do this on any list of words or sentences or anything like that. And so again, to accept an array of objects in a method is simply the matter of adding the brackets to our data type. So we'll call this one words. And now again, I would say pause the video, try to implement this method. The idea is we're going to be using val count to determine if it's within the range at least 2 vowels, and if so, we include them in our count. So I'll go ahead and pause the video, try it out, and then come back in a moment. So I hope you've done that. Let's try doing this together. I think the idea is very similar. We'll start off with a variable that represents how many, and again, there may be 0. And we're going to go through every single spot in the array, so we should do indices that are within range. 0 is the starting index of every array. As long as our I is less than words, dot length without parentheses, because remember, words is an array of strings, not a single string. We're going to look at every spot. We don't want to skip anybody on accident. And now our question can be, well, again, now we want to know how many vowels are in a string. We can get the current string and call this. Now, I couldn't do this in 2 lines. I'm going to do it in 1 line on purpose just to kind of see that it's the same thing. We should be comfortable with the idea that if you use bracket notation, what it's returning is basically the thing of the type that they gave us, in this case string. And so we don't have to put it in a string variable to use it as if it were a string already, because it is in fact a string. So we'll say words at I is the input, but we have to wrap this in the method, so we're going to say the val count of words at I, because words at I is a string, and if that is greater than 2, so we'll say at least 2, so greater than or equal to 2, then our count goes up. And again, now if you ask yourself, what is actually happening here, the reality is we have a loop within a loop. We just maybe don't see it, right? This loop loops however many times there are words in the array. This loop returns however many, loops however many characters are in the current string, and that might be many, many strings. And that's the idea here, is that we can easily, we have to be very careful when it comes to using methods, or at least aware. If a method has a lot of work in it, you might be amplifying the amount of work in total by doing it within a loop and an array. If there were 1 million strings, and each string had 1 million characters, that's a lot of work happening. Realistically, that might not be the situation, but still, we should always be aware of that kind of, I won't say danger, but situation of work that's happening. And then just like before, we go through every spot. When we're finished, we can return the count of how many were at least 2. Right? So it's a good idea to be able to try that out. So I hope this makes sense to everybody. We can see this is a common technique, determining if something's in an array or satisfying some condition. And again, this condition basically could be anything you could possibly imagine. If we're using integers, you might say, well, I need to know which numbers are prime numbers. I need to know which numbers are divisible by the number 17 and 21. I need to know if they're strings, which strings have 3 periods and 2 commas in them. I mean, there's no limit. And of course, if we use more complex objects, so for example, if we made bank accounts, we might say, well, I need to know how many bank accounts have a balance above 200. And we might have to call the getBalanceAccount method that exists in the class that we wrote. So there is no limit to the kind of condition, but at the end of the day, the idea is you look through the content, you make a decision, you increase a count somewhere, and take advantage of that. So this is a very common algorithm, and again, the variations are very much focused in what are you checking. Okay, So now the second example I want to follow, so this video won't be very long, so I'm going to finish it with the second example, is another common situation. And again, it is just one variation, but many problems are solved with the same idea. Is one of, as you loop through a collection of items, you might have to look at pairs of things or triplets of things, right? So this is a very complex idea because it is, we have to be very careful whenever we use indices in accessing items in an array. We have to be careful we don't go out of bounds in either direction. We don't want to go negative because there are no negative indices, and we don't want to go beyond or equal to the length because that would cause an index out of bounds exception. They're both dangerous situations. So we need to handle gracefully edge cases. And we've done this with strings, but let's confirm in our minds that the same rules, the same safety mechanisms that we should be following apply for arrays as well. So in this example, what we're going to do is we're going to be given a number, an array of numbers, whole numbers. We'll stick with something easy, whole numbers, integers. And we want to count the number of sequential pairs that exist in the string. So for example, if I give you the number 1, 1, 2, 2, there are two pairs. 1, 1 is a pair, and 2, 2 is a pair. If I give you the number 1, 1, 1, there are also two pairs. Because the first one, the second one is one pair, and the second one and the third one is another pair. So we're not going to skip pairs. We're not going to move by two, but we're going to look at every pair of numbers next to each other, so there's overlapping. And then if they happen to be matching, we increase our count. So this is still kind of a blend of the previous problem and this new idea. We are trying to summate something, figure out how many of the thing there are, but the trick is looking at items in an array next to each other. And the key to it is not complex. The key is make sure you don't go out of bounds on accident or end early on accident in either direction. So let's try this out. We'll make the signature. I'll give you a little bit of time to try it out on your own, and then we can implement it together. So we'll say public, static, just like the same reasons before. And again, the int will be the return type. We want to know how many of these pairings do we see. And now we'll say, we'll call it count pairs. Our input is an array of integer values, so we'll call this nums. So here we go. We have to think about going through from beginning to end. But just like when we did strings, there is one important factor. How far, in order to look at a pair, we must look ahead at an index. If we're at index I, we might look at I plus 1. Or we could also look backwards. If we're at index I, we could look at index I minus 1. Whatever we decide, we need to adjust our starting point or our ending point to handle that looking ahead gracefully. Because if we're at an edge case, for example, if we're at the last index, length minus 1, what is length minus 1 plus 1? It's length. But length is not a valid index in any array that has length items. It's always off by 1, and so we have to be very careful that we don't try to access memory that we don't have a right to. And so, in order to do this safely, we must end early. So here we go. Let's try this. I'd say pause the video, spend a few minutes, implement it, and then come back and let's see if we have the similar answer. And if we do, then you're definitely, you should be proud and hopefully have a good, strong understanding of dealing with arrays and the edge cases in indices. Okay, so if you paused the video and you tried this out, hopefully it went well, and let's see what happens with our implementation. Again, we'll make a count. We'll start off with 0, and we'll try to increase this number when a certain condition is met. We're going to look at every single pair of items. So the loop actually doesn't really change much initially. So int I equal to 0, I less than. I'm going to do it the normal way, and then we'll maybe adjust it. So typically we would say nums.length, because this is from 0 to length minus 1. This is a valid, safe range. We go every spot one at a time. And our question is pretty easy. We're basically asking for every pair, I and I plus 1 as indices, are you the same number? And if so, then we increase the count. But if they're not, then we move on. And we want to make sure we don't go out of bounds. So let's ask that question. We'll say, if the ith number, so nums at I, is equal to the ith plus 1 number, so nums at I plus 1, if they're the same, then we increase our count. It's pretty easy. Again, the real problem, and then again, if this finishes successfully, then we return to count. Now, the real problem is that the error is not a compile time error. The danger is a logical error. It is one that happens during runtime. If this goes out of bounds, which is possible, we will crash our program. So essentially, just like when we dealt with strings, the key to understanding it is if you look ahead some amount, you should stop early that amount. So since I looked ahead one index, I should stop early one index. To stop early one, I have two choices. I can subtract 1 from this, or maybe do less than or equal to and subtract 2. It really doesn't matter, but essentially it's taking away 1 from wherever you're currently stopping. So there it is, right? And so we're saying, look, since I'm looking ahead 1, I make sure to stop 1 early. And that way this I is never going to, I plus 1, which is the furthest end, will never go out of bounds. So this was one we should definitely test and prove that it works. So let's go to our main and try this out. So if we use numbers, we're not going to really have any duplicates. So let's go ahead and make our own array, another literal array that has some actual pairs in it so we can try it. So we'll say int array, we'll call it pairs, and we'll make a literal array, and let's fill it in. Let's do 1, 1, 4, 5, 5, 5, 6, 7, 6, 4, 4. So if we count how many pairs there are, we should see 1 pair, 2 pair, 3 pair, 4 pair. So we expect to see 4. Remember, in a set of 3, there are 2 pairs. The first pair is these. The second pair is these. So we should see 4 pairs. Let's see if that happens. Or if we get a crash, that could be a problem too. So we'll get our answer. We'll say int num pairs, and we'll call our method. Our method is called count pairs. So we can call it count pairs. The input is an array of integers. So I could pass in numbers or pairs. But we know numbers, if there are no pairs, so we'll get 0. We can test on that one as well. But let's try this out. And then let's print out our pairs. And we expect to see, hopefully, 4. And if we maybe made a mistake, maybe it'll crash, and that's a problem. But let's go ahead and run it, and let's see what happens. And there it is, 4 pairs. It looks like it's working out nicely for us. And then let's test this real quick. Let's do this as a 1. And now there should be 5 pairs, right? Because 1 pair, 2 pairs, 3 pairs, 4 pairs, 5 pairs. So let's run it. And there it is, 5. And then let's do one last test. Let's change the input to numbers where there are no pairs, and we should get 0. Oh, sorry, numbers. And we should see 0. And there it is, right? Just as a quick proof of the problem, let's pretend that we did not do the -1. We run it. We're going to see it's going to do most of the code, but it's going to fail on that last index, and we'll see an error. And if you look at it, index 11 out of bounds for a length 11, because remember, an index is always off by 1. So if the length was 11, the last safe index was 10. And let's count it: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 items, indices 0 to 10. So because we looked ahead, we said 10 plus 1, it was 11. Nums at 11 was not a valid choice. So it caused an array index out of bounds exception is the specific error that we get. And so we should not let that happen. So if we look ahead, we must stop early. They are connected. And if we had done -1, then we would have started later to guarantee that if we went backwards, we didn't go out of bounds, because negative indices is also an exception that may occur. So we should do -1. And I hope this makes sense. And again, we've done a lot of examples of different manipulations. There's no one problem to arrays. Arrays are used in all kinds of contexts. But if we are comfortable with these common techniques, the looping through, most of the loops we've done have been pretty common. It's important to be comfortable with iterating through arrays, because so much data is used in collection formats in the future and all the code we're going to do. So you need to be prepared to handle that in an intelligent, safe way. So I'll see you in the next video. We'll be moving on to other topics that are very much related. So hopefully, if you're good with arrays, the other ideas will become much easier to absorb, and we can move quickly.